Alright, this is Dr. Marion Carroll, and we're going to continue with our, I think it's lecture 7, this might be part 2. Nope, lecture 7, part 3. And I divide these up by parts because some of the information is very much relative to the other, and we haven't moved on to a new topic. But we were talking about bonding, and we'll talk about covalent bonding in terms of a triple bond formation. So if we look at a Lewis structure of carbon again and nitrogen, alright, nitrogen 2, 4, 6, 7, group 7, carbon is in group 4. There are actually 3 different forms that this can take. You can simply form a carbon-nitrogen bond by sharing one electron with nitrogen. Okay, it looks like this. And the other 2, 4, 2, 2, 4, 6, 8. Alright. Or a double bond. Okay, it looks more like 2, 4, 6, 8. We have 8 here, 2, 4, 6, 8 on nitrogen, and we're sharing 2, 4, 6, 8 carbon. And the third is a triple bond. Carbon and nitrogen. This is a very difficult or very toxic compound called cyanide. And its Lewis structure, you have 2, 4, 6 electrons being shared between nitrogen. Alright, and nitrogen has 2 more left. 6 plus 2 more on your carbon. Second one is being shared by hydrogen. Alright, so sharing of electrons, valence electrons, is what's important, and again, these are covalent when you share electron, ionic when you transfer. Now, sometimes we can create a situation where 2 different elements share electrons unequally. Alright, so the unequal sharing of electrons results in what's called polarity. And you can have polarity induced by the presence of a strong negative force or positive force, or it could be inherent in the molecule, it could be present in the molecule. So polarity results from 2 different elements. One is more electronegative, That is, it draws electrons to itself than the other. For example, water. Water is our classic polar molecule. It has oxygen with 2 unshared pairs of electrons and hydrogen. Now, because oxygen is much more electronegative, greater electronegative than oxygen is greater than hydrogen, and we'll use EM to designate electronegative, then the electrons tend to be drawn towards oxygen, and oxygen becomes more negative. And as a result, hydrogens become more positive. Okay? This is a delta symbol, lowercase delta. Uppercase delta is like this. Sorry. So the lowercase delta is what we refer to as partial negative charge. Uppercase delta gives us the symbol for a partial positive charge on this side of water. And so that is the nature of polarity. Let's talk a little bit more about electronegativity and polarity. And we'll conclude with a discussion of resonance, a very brief discussion of resonance. So, the periodic table is set up not only do we go the atomic number in this direction increases, in this direction it increases. So the atomic number of elements, if you look at your periodic table, around here somewhere. I'll pull one out, but you pull one out and look at it. The atomic numbers increase as you move this way, from left to right, and they also increase as you go down. As a result, what you find is that the atomic radius, okay, remember radius increases. So let's represent this as the group 1 element at the very upper left corner. Let's say it's hydrogen. And we move down to lithium. Okay, and then what's next? Sodium, potassium, rubidium, cesium. What you notice here is that the radius, and remember a radius increases as it goes down. Alright, a radius is simply the distance from the outer edge of the cloud. We're looking at electron cloud radius to the center, to the nucleus. Alright, this distance, alright, is referred to as a radius. It increases as you go down the table. Also, as you go across the table in this direction, what you'll see is that the radius begins to what? Decrease. Very gradually. There's a lot of elements, but nevertheless they decrease as you move across the table. Now why is that? Well, what's happening in this direction is that you're increasing electronegativity. And where we define that as it draws electrons. And so by drawing electrons, you squeeze in, alright, you cause the electrons to move inward towards the nucleus. Okay? Because the mass increases as you move across the table. As the mass increases, so does the positive charge of the nucleus. And the nucleus charge is positive, its mass is larger, and the electrons are negatively charged, its mass is smaller. They tend to be drawn in towards the nucleus. So the electronegativity increases as we go from left to right. You'll notice that most of our metals have a very low electronegativity, and our non-metals have a high electronegativity. Actually, one of the most electronegatives is fluorine. The least, we'll put it here, is cesium. It's the least electronegative. Alright, what else? We have ionization energy. We haven't talked about electronegativity. Ionization energy also increases in this direction. What is that? That's the energy required to remove the valence electrons. Okay? So the energy required increases as we move from left to right, left to right, left to right. And so ionization energy increases because elements that tend to be more electronegative, drawing the electrons towards it, tend to also require more energy to pull those electrons away. Alright, and so these are some of the patterns associated with the periodic table. Not only do the atomic numbers increase, alright, as you go down and across from left to right, you also increase a number of other properties of these elements as you move from left to right. Another property is electron affinity. Okay? Electron affinity, EA we'll call it. And electron affinity is the attractiveness of the electron, or the tightness of electron binding to the atom. Okay, so the energy required to remove electrons is obviously directly proportional to the affinity. The tighter the binding, the more difficult it is to remove, the more energy you need to remove it. And also, the more electronegative an element is, the more difficult it is to remove, the higher the affinity. So as you move from left to right, high affinity. Okay? However, as you move down the table, low affinity. up, down, as you move from up to down. Okay, so these elements down here at the bottom tend to have a lower affinity than those at the top, and those on the left tend to have a lower electronegativity than those on the right, and so forth. All right, that completes our discussion. We'll talk, I think, in part 4 about resonance and move on from there.